Imagine baking a cake, but no matter how much sugar you add, it stops getting sweeter. That's exactly how enzymes work in your body. Let's break it down as we explore the factors affecting the rate of enzymes. The first factor is enzyme concentration. As the enzyme concentration increases, the enzyme's catalytic activity also increases because more active sites become available where the substrate can bind. So as the enzyme concentration increases, the rate of reaction also increases, as shown by this graph. The red line indicates the relationship between the change in enzyme concentration and the rate of reaction. As seen, as the concentration of the enzymes increases, the rate of reaction also increases. The second factor is the substrate concentration. As the substrate concentration increases, the rate of reaction also increases until the point of saturation is reached, as depicted by this graph. A point of saturation, also called the limiting point, is a point at which all enzymes' active sites are bound. Therefore, enzymes become saturated. Beyond this point, any increase in the substrate concentration does not affect the rate of reaction. This is shown by the flat line after the point of saturation on the graph. The third factor is temperature. Enzymes work well at the optimal temperature, which has a range of 37 to 40 degrees Celsius. At low temperatures, the rate of reaction is low because enzymes are inactive. As the temperature increases, the rate of reaction also increases because enzymes gradually become active with the gradual increase in temperature until the optimal temperature is reached. Try this. If an enzyme's optimal temperature is 40 degrees Celsius, what do you think will happen if you heat it to 60 degrees Celsius? Comment below before I reveal the answer. Beyond the optimal temperature, the enzymes become denatured. A denatured enzyme loses its shape and its function as well, as shown by this graph. As the temperature increases, the rate of reaction also increases until the optimal temperature, which is about 40 degrees Celsius. Beyond this temperature, there is a sharp decrease in the rate of reaction because enzymes become denatured and can no longer catalyze the reaction. The fourth factor is pH. Each enzyme has its own optimal pH value where it works well. Some enzymes work well in an acidic environment, some in a neutral environment, and some in a basic environment. When the pH value is lower or higher than the enzyme's optimal pH value, the enzyme's catalytic activity decreases until it stops. The relationship between the pH and the rate of reaction is shown in this graph. As seen, the rate of reaction is maximum for each enzyme at different pH values. For pepsin, the enzyme activity is maximum at the pH value of 2. Below or above this pH value, the rate of reaction reduces. Trypsin is maximum at 7, and alkaline phosphatase is maximum at 12. Your stomach enzyme, pepsin, works best in a highly acidic environment, while your small intestine enzyme, trypsin, prefers neutral conditions. That means your body is like a well-calibrated chemistry lab. The fifth and last factor is the presence of the enzyme's inhibitor. An enzyme inhibitor is a substance that binds to the enzyme and decreases its activity. The presence of an enzyme inhibitor decreases the enzyme's activity and thus decreases the rate of reaction. To recap, there are 5 factors that affect the rate of enzyme activity. The first factor is the enzyme concentration. As the enzyme concentration increases, the rate of reaction also increases. The second factor is the substrate concentration. As the substrate concentration increases, the rate of reaction also increases until the point of saturation is reached. The third factor is temperature. Enzymes work well at the optimal temperature, which has a range of 37 to 40 degrees Celsius. Low temperature makes enzymes inactive, and high temperature denatures enzymes. The fourth factor is pH. Each enzyme has its own optimal pH value. Some work well in an acidic environment, some in a neutral environment, and some in a basic environment. The fifth factor is the presence of enzymes inhibitor. The presence of enzymes inhibitor decreases the rate of reaction. Enzymes are the invisible workers driving every chemical reaction in your body. And just like machines, they can be slowed down or even stopped. But do enzymes work? In the next video, we'll uncover how enzymes work and so much more. Stay tuned. Stay curious.